Welcome back. In this video we're going to be talking about mucosal immunity, and so we'll start off by asking Kim, what is mucosal immunity?
So mucosal immunity is the immunity or the immune response that happens at mucosal surfaces. So this might include the respiratory tract or the urogenital tract or the gastrointestinal tract, and the exocrine glands that are associated with these, so the salivary glands as well as the lactating breast. So it covers a very large area of the body.
So is it really different to any other immune response?
The mucosal immune system is unique in that it has to deal with both pathogens and exposure to non-pathogenic antigens on a regular basis. So mucosal surfaces are thin and permeable, and they're designed to interact with the environment. So you think about the gut, you want food to come in and you want those the energy from food to be able to pass into your body, and that's going to happen through the epithelial wall, so it's quite thin. But this obviously means that it's more susceptible to pathogens, and so the mucosal immune system has to deal with that unique challenge. And it's thought that the mucosal immune system does develop separately in parts to the adaptive immune system.
So we've learned through the semester that the immune response often is the simplistic immune response is antigen presenting cell, processing, T cells and B cells. Would an immune response at the mucosal surface be much different to that, or is it more specialised?
While the same cells exist in the mucosal immune system, they are skewed towards tolerance. So the macrophages, for example, are not very good at expressing co-stimulatory molecules. So they're unable to activate T cells or B cells, and they don't migrate as well through the lymph system. So they're more static. There are a lot of T regulatory cells. So again, the immune system is designed with the knowledge that it will be exposed to a lot of innocuous antigens, and so needs to be on alert but not actually do anything most of the time.
We're just thinking about these mucosal surfaces. I'm thinking about the lung and the gut, for example. Is the immune response at those sites very similar?
They're similar. They're not identical in all of the sites, but the mucosal immune system we know best is the gut-associated mucosal immune system. So a lot of the research is in that field, and a lot of our understanding comes from there. So there are some differences within the lungs or in other areas of the body, but we don't know them as well as we know the gut immune system. And we have learnt relatively recently, for example, that parts of the gut immune system, because it's so large compared to the rest of the body, is that some of the cells that are activated in the gut or the antibodies that are produced there are able to go to other areas. So, for example, the lactating breast is not really an ideal site to mount an immune response, but the plasma cells that are produced in the mucosal immune system can move into that site, so to provide antibodies to an infant.
And it's very topical these days that apart from food in our gut, we've got a lot of bugs and bacteria. So is there a connection between those two?
There absolutely is. So we have more bacteria and viruses and fungi inside of our body than we have human cells.
Get out.
And so we call these a microbiota, or our commensal bacteria, and these help shape our immune system. So if we did not have these in our body, our immune system wouldn't develop properly and we'd actually be quite unwell. So they're integral to our health, and what we eat feeds them. So the types of food we eat will influence the type of microbiota we have, and then the type of microbiota we have influences the immune response we have. So it's a complex interplay between the two, and you need both parts to play their role, and they're both really important. They're believed to be important in some chronic diseases. So if we can increase the number of good bacteria that are anti-inflammatory, that might help with chronic inflammatory diseases. And there is research in this field to suggest that high fibre diets will feed those good microbiota, which will allow inflammation in the body throughout the entire body, not just within the gut, to become a bit more settled, a bit dampened down, and that can help with a lot of different conditions. So rheumatoid arthritis, for example, might be helped by eating a high fibre diet.
Okay. And just to end off, can you give us a idea of how we could actually view a real-life lymphoid organ associated with our mucosal system here and now.
You could look in your throat. Your tonsils and your adenoids are part of the mucosal immune system. So if you've got a mirror and a torch, you could probably have a look unless they've been taken out.
Except for me, who was taken out when I was 8, I think. Anyway, thanks, Kim.
Thank you.